So this is a Turing-funded project that I'd like to share some of our thinking on, working with people at Newcastle University and Nick Lomax at Leeds, amongst others. And the idea is we're trying to think about what a strategic long-term digital twin might look like for land use planning decisions here in the UK. Why is this interesting? Well, for a number of reasons, but we're coming at this really from a climate change perspective, both from a mitigation and an adaptation point of view. Where we put things, where we build new urban developments matters for both things like decarbonising transport and avoiding lock-in to car dependency, but also ensuring climate resilience in the future as well, to make sure we're not building new homes and infrastructure in places that increases their exposure to future climate hazards. So this was recognised in the Planning for the Future white paper last year. Whether this goes ahead or not is open to debate, but there is a policy context there. What we've been doing is thinking about the kind of regional picture. We've been doing a lot of work on the Oxford-Cambridge arc, and now we're applying some of the same ideas to the Northern Powerhouse region. Again, last week's transport announcements may have thrown a bit of confusion into the mix on the Northern Powerhouse future. But the idea is, how do transport infrastructure investments lead to urbanisation, and how do those urbanisation patterns then lead to changes in emissions from transport or exposure to future climate hazards when they come. Why we want to try and use spatial models and urban analytics for this is because there's a requirement for kind of integrated spatial planning. There are a lot of competing demands on land and competing demands on the people who are planning the future use of that land. So we can see, you know, land use plays into things like decarbonisation strategies for transport. There's also Homes for the North, an organisation thinking about housing requirements and where we put future housing to ensure there is enough of it. There's also organisations thinking about protecting nature, and clearly these different roles and responsibilities have trade-offs, tensions and potential co-benefits. So there are things we're trying to do with land use planning: provide enough land for housing, avoid putting that housing in places that increases flood risk, maybe build near new public transport hubs, transit-oriented development type of ideas, protect natural capital and biodiversity, provide land for employment, lock in sustainable transport, walk and cycling, etc. So some of these things might play together and some of these things might play against each other. And what we want to do is use these models to try and expose some of those tensions, but also try and find win-win locations where we build near to jobs to enable active travel, but also avoid building in floodplains and also protect natural capital, etc. We've called this a strategic digital twin. In the Gemini principles from the Centre for Digital Britain, there is this idea that we need a strategic planning model for the land use system that allows us to think long-term, explore different options, and then get feedback from the physical real system that Mike was just explaining in his talk through the kind of local authority data on where houses are being produced, or infrastructure providers data on energy use or transport use, etc. So there's this idea that this is long-term digital twin over the course of decades, not a minute-by-minute, second-by-second digital twin. What we've been trying to do is explore some of these long-term scenarios through competing dimensions. So we might think about urbanisation as a set of new settlements versus expansion of existing settlements, for example, and then explore different kind of green versus grey. Grey might be existing development paradigms where we build sprawling car-dependent housing on the edge of cities, and green might be high-density housing around public transport hubs. And what we want to do is think about what the spatial factors are that drive each of these different scenarios, and then simulate them through a set of urban analytics or data analytics. So we're rasterizing data sets essentially into a grid. So we might take master map data and say, well, this tile's full of buildings and man-made surfaces, human-made surfaces, and this therefore is current development. This is a bit of water, that might be something we don't want to build on. This is a field with no planning protection, so that might be somewhere that we develop in the future. And we create grids like this. So this is the Oxford-Cambridge arc, where we have suitability surfaces essentially that say the dark areas are places we don't want to build in the future because they're protected. And here we've got grey versus green, more protection in the green scenario for nature and wildlife corridors, etc. And then we have a suitability score that attracts new development to certain locations. And what that leads to then is maps of the future like this, where we can say for those given scenarios, we might get different future development patterns, new settlements up here, springing up along the Oxford-Cambridge arc in this case, and urban expansion down here, and then we've got grey versus green urban sprawl versus higher density development. And what we want to do then is explore this locally, so we can look at the density of those development areas. So we've got higher density around rail stations and lower density elsewhere. Why are we doing all this? Well, for things like this. So what we want to try and explore is things like future climate resilience. So here's the Clyde region where we've been testing some of these models. We've got a future population scenario for 2080 from the UK SSP scenarios that give future scenarios of how the UK might develop, and we convert that to urbanisation, and then we plug that into a hazard model, in this case a flood model. So we get this urbanisation leading to changes in flood risk, and then we think, well, if that flood risk is too high, we need to go back and adapt, either by building in different places or encouraging people to live in different places. And this is where we've got the digital twin idea, that we're starting to try and explore these long-term futures, feed it back into planning policy, and then that goes forward. This model is being built on Daphne to allow national scale simulations for anywhere in the UK. We've built a set of free and open source tools that take national open data sets. These are all on GitHub if anybody wants to play with them, and generate those kind of UDM maps I've just shown, the urban development model outputs, and build a flow chart, a flow workflow to actually simulate these kinds of outputs. The next step finally is to actually do this in anger and allow planners to use these tools. So we've had a series of workshops in our Turing funded project with people like Transport for the North and Newcastle City Council to think about how we might use these models in anger. It currently looks like this, a nice kind of schematic of what a decision support tool might look like. But the plan is that we provide tools to planners who can then actually try out these scenarios themselves, explore these competing demands on land, and try to understand, is there an optimum future development pattern for any given city in the UK. That's the idea. And thanks for your time. Hope I didn't run over too much today.